Welcome to Business Math. Today happens to be Wednesday, February 19th. We're going to go back and talk a little bit more about standard deviation. One of the things that I've already mentioned this before in my first lecture on standard deviation, I gave the example of data about two football players. One of the football players had a really high mean, but was real inconsistent, meaning this football player sometimes got thrown for a 10-yard loss and then sometimes ran for 90 yards, okay? So the data was very, very spread out. The data was very spread out, okay? Then the other running back, and I call the other running back the fullback, the fullback, he's a really big guy, and he really actually can't run very fast. Now, most of you are too young to have seen the refrigerator play. They used to call him the refrigerator. And once in a while, they would actually, the refrigerator very, 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 I think he played for Chicago. Any of you remember the refrigerator? The refrigerator Perry was his name. Anybody remember him? Nobody. Oh,
yeah.
John.
Played on 1985 big team.
This guy he played for Chicago, right?
Yes, sir.
Chicago Bears. And this guy was huge. Now, he couldn't run fast at all, but, oh my goodness, did he weigh over 400, Jonte?
He weighed about 350, somewhere in there.
Yeah, 350, 375, on a good day after he ate his Wheaties in the morning or something. But anyway, you give the ball to this guy, and he couldn't run fast at all. But, oh my goodness, he was consistent. So his longest career run was probably 5 yards. But the point is that if you wanted him, he could consistently get 3 yards almost by, you just give him the ball, he'd start leaning forward, and he was so big that people would just bounce off him. So he had a very low mean average run for his per run, but he was very consistent, very low standard deviation. See? So on a short yardage situation, that's the guy you want to give the ball to, because it was pretty much guaranteed that the fridge could pick up 3 yards. Okay? So that's what you do. Especially if you needed only 2 or 3 yards, that was it. You give it to him. Now here's another example of high standard deviation, low standard deviation. And that comes to investing. In investing, you will have, it's called volatility. It's like a roller coaster. The little kiddie roller coaster, it doesn't go very up, very high. It's just kind of smooth. It goes through nice little curves, things like that. That's the kiddie roller coaster. Then you have the roller coaster that it goes straight up, and then it just plummets straight down, and you can hit speeds of 90 miles an hour on a really good roller coaster, and they're awesome. So they go way up and they go way down. Now that is similar to what we call a highly volatile investing environment, where some years you may, let me give you an example in my life, okay? One year I took my trading account and I tripled it. Wow. Now, by the way, if you're really good at percent of increase, we probably should go back and review that, huh? I took one of my rental properties, and I said, you know, I've got a trading strategy here, and I think this thing might work. And it turns out, granted, it's a long story, and granted, I benefited from some things in the market that I actually, in other words, I was lucky. Okay. But I took an account. I sold a house for $30,000. I put this into an account, and in 1 year, I tripled it. By the way, just to make sure you're still paying attention here, since I tripled it, what was at the end of the year? This was actually 2009. What was the value of that account at the end of the year, Shay?
The projector's not working in here, so we don't have that.
Oh, you don't have. Oh my goodness.
Yeah, it just stopped working this morning.
This died this morning. Well, that's too bad. That means I appreciate you telling me, because I'll have to be very careful about how I ask questions. Well, I just wrote I wrote 30,000 down on the screen, and that was the amount in the account at the beginning of 2009, and then my account tripled. So how much was in my account at the end of the year, Shay?
90,000.
Yeah, 90,000. So that was what was in the account at the end of the year. So that was a good year. Now, if you're really good at percent of increase, by the way, Alvis, if you guys are handicapped today, you're going to have to write this down. You got to write down 30,000, and then you got to write increase to 90,000. Okay, it tripled. So now you're going to have to really, really write things down so that you'll have the visual in front of you. The question is, what's the percent of increase? What's the percent of increase? I'm writing that on the whiteboard now. What is the percent of increase? What is the percent of increase? All right, what is the percent of increase? Now, hopefully you remember how to compute percent of increase. Let's see, do you remember how to compute percent of increase, Courtney?
The increase divided by the basis.
You are awesome. The increase divided by the basis. So that's just what I wrote on the whiteboard, Alva. Increase over the basis. So now you're going from 30,000 to 90,000. So what's the increase, Robert?
60,000.
60,000. So I write that in the numerator. So I'm just going to, if I keep everything in thousands, I can just write 60 in the numerator. I don't have to write 60,000. And in the denominator, let's see, the basis is going to be what, Wyatt?
30,000.
30, because that's what you started with. And now when you compute this, 60 divided by 30 is how much, Jonte?
20,000.
You get 2 points for your good participation. Rachel, what is 60 divided by 30?
2.
2 is it. I'm not very good in the morning either, Jonte. In fact, the only reason I'm awake is because I'm talking. Well, you get 2. Now you got to change that to a percent. So change 2 to a percent for us. Jay. How do you change that to a percent?
You move the decimal point to the right.
Very good. So you take the 2 and move the decimal point 2 places to the right. So we get 200%. Now, if you're really good at percents, as soon as I said that my account tripled from 30,000 to 90,000, boom, you knew that was a 200% increase. Now, if you're not too good at percents, like most Americans, As soon as you tell somebody my account tripled and it went from 30,000 to 90,000, most people will say, oh, that's a 300% increase. It's not, is it? It's a 200% increase. Now, it is correct to say that 90,000 is 300% of 30,000. That's a correct statement. 90,000 is 300% of 30,000. But I didn't ask for that. I asked for the percent of increase. The percent of increase is 60 over 30, which is 2, which is 200% increase. All right. Now, finally, we're going to get to the point. All right, so 1 year I had a 200% increase. 2011 was a great tax write-off year for me. What does that mean, John Tate?
It means that you was getting some money back.
I lost big time. I lost $160,000 just in 1 month. That was in August. And at one point in time, my account was all the way up to $293,000. And boom, I lost $160,000. In fact, then I continued to lose, and my rock bottom was at about $62,000. All right. Well, I had a great tax write-off for that year. And so my loss that year, I made part of it back before the end of the year. And so if I go just on the year of 2010, I'd say on 2010, I lost probably about 60% of my account in 2011. From the start of 2011 to the end of 2011, I'd have to go look it up, but I think I lost about 60% of my account. Now you say, gee, what's the point of this? How's this related to standard deviation? Well, I'm telling you that 1 year I had a percent of increase of 200%. Another year I had a percent of decrease of 60%. I'm all over the place. Do you want to invest money with me, Wyatt?
No.
You're going to hurt my feelings. Minus 8,000 bonus points for Wyatt. He doesn't even know how to suck up to the professor. No, you're right, Wyatt. That is not a wise thing to do because, you see, in fact, when you're investing with somebody, what's really important to you probably is some consistency. Most people can't stomach losing 60% of their account in 1 year. However, let me tell you, now this is just the facts, all right? You have to be ready for that if you're investing in the stock market, even if you're investing with somebody that has way more consistent results, which means smaller standard deviation. See, my results are just all over the place. And hopefully, before I die, I will learn how to trade stock options a little bit more consistently. So that I may not have any of those 200% gaining years, but hopefully I won't have any more of those 60% loss years. But I want to warn you, in the stock market, even if you pick somebody, even if you pick a total professional that manages money for a living, I hope most of you realize that professional money managers, even though we're invested in the top 500 stocks in the United States, known as the S&P 500, great 500 great companies, very large companies, and large companies do better in a downturn in the economy than small companies, okay? But anyway, so you got the S&P 500 from October 2007 to March 2009, the S&P 500 lost 58%. So it can happen, and it will happen. Now, nobody knows how big the next downturn is going to be. Nobody knows. Maybe it's going to be 30%. Maybe it's going to be 60%. Maybe it's going to be 90%. Nobody knows. All right? So what I'm talking about here is how far the scores are spread out. Now, let's take a look at an example. And Alva, you're just going to have to write these down. I appreciate you telling me that your whiteboard died. But you're going to have to write these numbers down, okay? And we're not going to make this too complex here. These are scores on a 10-point quiz, okay? These are scores on a 10-point quiz. So I'm going to write these scores down, and you can write them down with me, Alva. These are scores on a 10-point quiz. We had a 1, a 3, we had a couple of 5s, so I have 1, 3, 5, 5. We had 3 6s. How many scores do I have? 1, 2, 3, 4, 5, 6, 7. We had 1 7, and then we had a 10. All right. So the scores, hopefully, Alva, you have these written down. 1, 3, 5, 5, 6, 6, 6, 7, and a 10. There's not 10 scores there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to add another 7. So you got 2 7s, all right? So you have a 1, a 3, 5, 5, 6, 6, 6, 7, 7, and a 10. Now, we're talking about the concept here. This is the important concept called dispersion. That just means how far are the scores spread out? How far are they spread out? So this is a measure of dispersion. When you're spraying your fertilizer on your lawn, you want to have a nice sprayer that results in good dispersion. Spreads that fertilizer all over your lawn. Okay? So dispersion, that's D-I-S-P-E-R-S-I-O-N, I believe. Dispersion means to spread it all out. Well, one measure of dispersion is just to take your low score, 1, subtract it from your high score, 10, and 10 minus 1 is how much, Robert? 9. You don't know German, do you, Robert?
I know 9 means no.
10 minus 1 is 9. So 9, we call that the range. We call that the range. So what we can do is we can use that as a measure of dispersion. Now the only trouble is you could have 2 sets of data. The first set of data that I wrote down was 1, 3, 5, 5, 6, 6, 6, 7, 7, 10. And the range is 9. Now here's the next set of data. I have 5 1s, 1, 2, 3, 4, 5. 5 1s and 5 10s. 1, 2, 3, 4, 5. So I have, Alva, I wrote down 1, 1, 1, 1, 1, in other words, 5 1s. And then I wrote down 10, 10, 10, 10, 10, in other words, 5 10s. So, and I wrote those in red. So the range of the second data set, what's the range of the second data set? Courtney. Oh, a little louder, Courtney? Yeah, 9 is correct. So 9 is the range. Now these 2 data sets, they're as different as night and day, but they both have the same range. The first data set is 1, 3, 5, 5, 6, 6, 6, 7, 7, 10. So there's kind of a nice little bell-shaped curve thing going on there. The scores are kind of clustered around 5 and 6, more or less. The second data set, 1, 1, 1, 1, 1, 10, 10, 10, 10, 10. Wow, they're spread out. You either knew it or you didn't, pretty much. And so, but you still had a range of 10. So we need some other way to measure dispersion besides range. So range is just one way to measure dispersion. So a second way to measure dispersion. Well, what we could do is we could figure out the average. Okay, keep your first data set, that 1, 3, 5, 5, 6, 6, 6, 7, 7, 10. Keep that data set. Erase the data set, or just, Alva, you don't have to erase it. Just, we're not going to look right now at the data set of 1, 1, 1, 1, 1, 10, 10, 10, 10, 10. We're going to compute the mean of this data set, 1, 3, 5, 5, 6, 6, 6, 7, 7, 10. So, grab your handy-dandy calculator out. Oh, by the way, how do you calculate? You don't have to tell me what it is, but how do you calculate mean? Rachel, how do you do it?
You add all the numbers up.
Correct, and then that's the first step.
And then divide it by the number of...
You got it. The number of data points. Or in this case, the number of scores. Good job. So, go ahead and do that. Take your handy-dandy calculator now. And add all those up. And what'd you get for your total when you added them up, Shay?
Oh, I got 56.
Oh, what'd you get?
56.
That's what I got. So if we're wrong, at least they're both got the same wrong number, right? So the sum of all these, and by the way, when you write mathematical symbols, the sum, we use the Greek letter sigma, and we're summing from I equals 1 to 10 of all of our data points. That's what that means. This actually is x sub 1, this is x sub 2, this is x sub 3, and so forth, all the way down to x sub 10. So we're going to add those up, and the answer we got was 56. All right. Now, Rachel told us how to do the mean. You have to add them all up and divide by the number of scores. So we're going to have to divide by 10. So what's the mean, Jonte?
The mean is 5.6.
5.6. All right. So the mean is 5.6. All right. Now, what I'm going to do is I'm going to cheat because we're running out of time. Okay? So I am going to cheat. I want this total, instead of to be 56, I want it to be 60. So I'm going to cheat, and I'm going to replace 6 with a 10. So I'm going to scratch out a 6, and I'm going to add one more 10. Okay? So do that now. Scratch out a 6, add one more 10. That should bring the total up to 60 right now, correct? I think so. Is that correct, Shay?
Yes.
If I scratch out a 6 and add a 10. So that should bring the total up to 60. And now 60 divided by 10 is a nice integer 6. Now here's why I wanted to do this, because we're running out of time. We only have about 5 minutes left. What we're going to do is we're going to find out how far each one of these scores deviates from the mean. Oh, you can even smell standard deviation coming, can't you? So now, Alva, you've got to do this. Since you can't see what's going on here, I've got to adjust this slightly. I'm going to put, I had 2 7s and 2 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a 1, 3, 5, 5, 6, 6, 7, 7, 10, 10, all in a vertical column. By the way, Alva, if you don't have those in a vertical column, put them in a vertical column right now. 1, 3, 5, 5, 6, 6, 7, 7, 10, 10. Put them in a vertical column, okay? Now what we're going to do is we're going to take our mean and subtract 6 from every one of these. We're going to subtract 6 from every one of these. This could be, basically what we're doing is we're finding out the deviation. So 1 minus 6 is negative 5. 3 minus 6 is negative 3. 5 minus 6 is negative 1. 5 minus 6 is negative 1. 6 minus 6 is 0. 6 minus 6 is 0. 7 minus 6 is 1. 7 minus 6 is 1. 10 minus 6 is 4, and 10 minus 6 is 4. Now you know why I got rid of that, why I cheated and made the mean equal to 6, right? So, this tells you the deviation of every score from the mean. The deviation of every score from the mean. Now, one of the things that I could do is, and this is a fairly decent concept it's not called the standard deviation, but we could call it the average deviation from the mean. This is another method of dispersion. We can figure out the average deviation from the mean. And we could just call it, not the standard deviation, but we could call it the average deviation. So, we could we could take absolute value of every single one of these, negative 5, negative 3, negative 1, negative 1, 0, 0, 1, 1, 4, 4, meaning when we're going to do this, the absolute value, we're going to turn them all positive. Okay, now those are all positive, already positive. So now what we're going to do is, we're going to take 5, because the absolute value of negative 5 is 5. Absolute value of negative 3 is 3. Absolute value of negative 1 is 1. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 1 is 1. Absolute value of 4 is 4. Absolute value of 4 is 4. Now we're going to add up 5 plus 3 plus 1 plus 1 plus 1 plus 1 plus 4 plus 4. I said that pretty fast. We're going to add up 5 plus 3 plus 1 plus 1 plus 0 plus 0 plus 1 plus 1 plus 4 plus 4. And then we're going to divide by 10, and that will tell us the average deviation. So, let's see, quickly add those up. 10. Wow, I think that added up to 20, didn't it? Did I do that right? Oh yeah, that's what you got, 20. So if we take 20, oh, by the way, mathematically, here's what the symbols look like. And don't panic, I may have to put this chapter 5-3 off a little bit further, okay? Because if we run out of time, I'll just do this again next Monday. This is from I equals 1 to 10, and now we're going to take the absolute value, that's what this means, these vertical bars, and we are going to take every score, x sub I, and subtract the mean, which is x bar. So I hope they get the smartboard fixed by Monday, because you can't see that, Alvin. That's extremely important. Anyway, we add those all up, and we got 20. But then we have to divide that by the number of scores, so we had 10 scores. So our average deviation turned out to be 2. That means, on average, every score was 2, on average, from the mean. Now, you know how math people like to make things extra complicated. It's horrible. We do this. Now, I'm not as smart as the people that came up with the standard deviation formula, so I would have left it. I would have just said, hey, average deviation. Merry Christmas. It's easy to understand. You take every score, calculate the mean, subtract every score from the mean, take the absolute value of those, add them up, divide by the number of scores, and there you go. You got the average deviation. Now, unfortunately, mathematicians didn't stop here. Wish they would have, right? What they did was that they continued, and we'll have to pick this up on Monday, but they took all of those deviations and squared them all, just to make life complex. So 5 squared is 25. They squared that. Then they squared the 3 to get 9. They squared the 1 to get 1. Square 1 to get 1. Square 0 to get 0. Square that. Square 0 to get 0. Square 1 to get 1. Square 1 to get 1. Square 4 to get 16. And square 4 to get 16. So these are the squared deviations. 25, 9, 1, 1, 0, 0, 1, 1, 16, 16. Then what they did was they added up all of those. I told you this was poke yourself in the eye with a sharp stick, didn't I? I wasn't kidding. So now you add up the 25 plus the 9 plus the 1 plus the 1. Well, let's see, that's 11, so I'll do that. Plus the 1 plus the 1 plus that's 2. Plus 16 plus 16, so I got to add 32 more onto there. So I got a total of 70. When I add all these up, I get 70. When I add all those up, I get 70. And now to sort of undo that squaring process, you take the square root of 70. I'll go over this again on Monday, so don't panic, okay? No panicking allowed. So now I got to do the square root of 70, and there's my answer. Answer 8.36 in a bunch. I'm just going to say 8.4 is the standard deviation. We'll go over it again more on Monday, so no panicking allowed. And I will give you more time on that 5-3 assignment. I'll put that off until all the way next Monday, okay? So you guys did great today. Appreciate it.